Now, a division of space into regular or irregular polygons. In here, for example, we see A and B. These are two examples of irregular polygons, and then we have regular polygons in C, this example right here on the right. These are different ways we could divide up a space or spatial domain, the spatial domain being the region in which we want to observe things in geographic space. We can divide them up into things like this, a tin or triangular irregular network, where we use triangles to divide up space. And some triangles are bigger than others. Or we could try making all the triangles around the same size. Or irregular polygons. These are Tessellation or Voronoi polygons, two names for the same thing. These are irregular polygons. Some are bigger and some are smaller. And then finally we have a regular division of a spatial domain into chunks or quantas, cells, like this. And the third one here, with the regular division, is much easier for computing to handle. So we have to use special algorithms to deal with cases A and B, which are time consuming and computationally burdensome. But when we have divided space up into regular square grid cells, this works very well with computers because they're built to work with things called numeric arrays, which are just like what you see in a spreadsheet, like in Microsoft Excel, a bunch of numbers. And a raster is a regular division of space where each of the cells we'll see has a number associated with it, just like a spreadsheet. And this approach to dividing space into a two-dimensional set of discrete chunks is also called quantizing space. So the quantization of space into individual cells, or quanta. Although that terminology here is not used very frequently, if at all, in most of the textbooks that you'll see. But it's just good to know anyway. One other thing about the previous set of slides is that all of those were also tessellations of space. A tessellation is when we simply divide up space into a set of polygons, which are non-overlapping and adjacent to each other such that there are no holes or gaps within the space that we divide up. And so when we do that, we're imposing a spatial structure on space, and then we observe things in that spatial structure. For example, in each of the little squares, we also call them cells, and sometimes pixels. Pixels as well is another term we use for that. But pixels is mainly used in the context of images, and cells in the context of rasters. Raster, thematic rasters. Thematic rasters are cells or contain cells, and images contain pixels. But we'll see a little bit more about that in the next few slides. So here's an example of a raster layer, which shows different things in reality modeled in cells. So if we blow up that little chunk here, we'll see that we have some brownish cells, some bluish cells, and then some various green colored cells as well, the dark green and light green. And there's different colors all around here. This is an example of an image. So an image raster. And then on the right-hand side, we have examples here, such as this little spot here. If we look at it and blow it up, we zoom in, we see it looks like that. Again, that's where we see the regular cells. In the image itself, we don't see those cells from far away because they're so small. But the basic raster model then simply divides space up into these regular cells and then records things in